Hi, I'm Karen St. Germain, and I'm NASA's Director of Earth Science. Often when people think of NASA, they think of human exploration or planetary exploration. They might not know that NASA has 23 satellites looking down at our Earth system to help us understand our home planet. We've been observing the Earth for decades, and we observe the atmosphere, the oceans, the land, the entire Earth system. And I'm going to talk to you today about what we know from those observations. This is an example of the kind of sustained observation that NASA satellites make, starting in 1993 until just our recent launch of the Sentinel-6 Michael Freilich satellite. We've been observing directly measurements of sea level height. And from those data, we know that sea level has risen on average 90 millimeters just since the early 90s. Well, what's causing the sea level rise? We all have heard about greenhouse gases, and I'm going to talk to you today about two of them. The first one is carbon dioxide, and of course carbon dioxide permeates our atmosphere. But by just adjusting the color so I can emphasize the maximum areas of emission, I can show you where carbon dioxide is and when carbon dioxide is being emitted into our atmosphere. Carbon dioxide accumulates most during the northern hemisphere winter months. Carbon dioxide is created by the burning of fossil fuels, and that carbon dioxide accumulates in our atmosphere over the course of the winter, and it's only in the spring, with the emergence of vegetation, that it starts being removed from the atmosphere. Carbon dioxide left in the atmosphere lasts for a very long time, and that's why there's so much conversation about carbon dioxide as one of the critical greenhouse gases. But on the next slide, I'll show you the other big greenhouse gas, methane. So while carbon dioxide is produced from the burning of fossil fuels, methane is produced from the extraction of fossil fuels and also from agriculture and vegetation decay. Methane is about 20 times more potent a greenhouse gas than carbon dioxide, but the good news is its lifetime in the atmosphere is much shorter. It lasts only around a decade. And so when we talk about mitigation types of decisions, it really matters to understand where the greenhouse gases are coming from and how they play in the atmosphere. Next slide, please. So what do greenhouse gases do? Well, they trap a lot of the sun's energy in the Earth system. And that's raising surface temperatures around the world, over both land and ocean. And we can estimate the total extra heat trapped in the Earth system since we started making satellite observations around the year 2000. Next slide, please. So where does all that heat go? Well, it turns out today, about 94% of it gets trapped in our oceans. Water has an enormous heat capacity. That means it absorbs a lot of heat before its temperature goes up. And you know this if you've ever put a pot of water on the stove to boil. But that heat doesn't stay put. Our oceans are incredibly dynamic with currents and eddies that carry that energy around the world and impact coastlines and coastal communities, weather patterns, and more. And I'll just talk to you about a few of the impacts from the heat trapped in our oceans. One of those impacts is in the Arctic. You're looking down at Arctic sea ice, and this is data from just this year showing you the extent of the Arctic sea ice. This is frozen ocean. Well, over the course of the summer, of course, that sea ice starts to melt, and that extent shrinks. Well, we've been looking at Arctic sea ice for decades now, and we know that every year at the end of the summer, there's less and less ice. Why does that matter? Well, ice is white. It's one of the great reflectors of the sun's energy. So in the summer months, when the sun is beating down on the northern hemisphere, the less ice we have, the less power we have to reflect the sun's energy back out into space. And this year, the end of the summer minimum extent was substantially less than it has been in recent decades. Another way that the warming oceans affect the coastlines is through the impact on land ice. So land ice flows through glaciers to the oceans. And at that boundary, that warm ocean can erode the underside of the glacier, causing it to thin and eventually break off. And that is like a cork getting popped out of a bottle. It increases the flow of ice from land out into the oceans. And we know how much of that is happening. Next slide, please. The two biggest ice sheets are Antarctica and Greenland. And we know where that ice is flowing from land out into the ocean, and that these two ice sheets alone contribute 1/3 of the total sea level rise that we observe. And we know that in part because we make direct measurements of the mass of the ice on these ice sheets, so we know how much mass has been lost from land, transported into the oceans. So why do we care about sea level rise? Well, one of the reasons is our coastal communities. We project a dramatic increase in just sunny day high tide flooding when high tides ride on top of that sea level rise. But there's more. Next slide, please. Our Earth is a water planet. And you might ask, well, if I live inland, why does this matter to me? Well, all of the water that we need to sustain life inland, to grow crops, to drink, all of that water comes from the ocean and it's delivered to us by the atmosphere. That's the water cycle. And one of the things that we're seeing with climate change is an increase in the magnitude of that water cycle. Wet regions get wetter, dry regions get drier. Next slide. One of the ways that wet regions get wetter is through the intensity of tropical storms and hurricanes. We all know that when tropical storms pass over warm water, they intensify. Well, all of that heat that's getting trapped in the oceans and warming the oceans, that's fuel for hurricanes. And we're seeing more and more hurricanes intensify, sometimes intensify very rapidly. And then, of course, when they make landfall, depositing all of that moisture over land and sometimes stalling for long periods of time, causing extended flooding. We also see flooding inland along our rivers and our watershed areas. And of course, inland along the waterways is often where we have agriculture regions, and that's impacting the agriculture yield there as well. Speaking of agriculture, there are two ways that climate change can impact agriculture. One we just talked about, wet regions getting very wet, but the other extreme is also impacting agriculture, and that is drier areas receiving even less moisture. When the temperatures go up, the demand that plants have for water also increases. So this combination of increasing temperatures and changing precipitation patterns is exacerbating drought conditions and adverse impacts on agriculture around the world. Next slide, please. And we can project this out into the future. So I'm showing you here future projections of maize or corn production as well as wheat production. Red areas will have lower yield and green areas will have higher yield. So you're seeing a dramatic shift in where and what crops can be grown. One of the reasons that this is important to us is we might think of maize or corn as food for us and food for animals, but also maize is used in many, many household products, from wallpaper to adhesives to batteries. So when we talk about a major change in the ability to produce maize, we're really talking about substantial economic change. Next slide, please. With increasing drought and dry spells around the world, we're also seeing a change in the patterns of wildfires. We're seeing extended wildfire seasons with less time for recovery in between wildfire seasons. We're seeing more severe wildfires and more rapid growth of wildfires. And this matters not only because the fire damages the immediate area, but it also increases the carbon dioxide in the atmosphere, and it has an adverse impact on the air quality in the region, in addition to making the region vulnerable to cascading effects like landslides when the rains do come. Next slide, please. So I've talked you through some of what we can see from our satellites and some of what we understand from our satellites, and now I want to talk about how we model those changes to give us predictive capability. So now I'd like to take just the last couple minutes to talk to you about how we try to bring that predictive capability to people who have decisions to make. One of the tools we use, or we've developed, is called the FIRMS tool. This is a tool that uses our highest resolution visible and infrared imagery to identify fires around the world, whether they are intentionally set for clearing fields or other purposes, or wildfires that are threatening local communities. This tool allows decision makers to understand where those fires are happening and how long they've been burning. And finally, the last tool I'd like to show you is one we're really proud of. This was a partnership between NASA and the IPCC to make the projections from the recent IPCC assessment report real to people. So communities around the world can use this tool by just locating their position on the map. They can zoom in and find out what we know about sea level rise so far in their region, and also project out into the future so they know what they may be facing. So, in summary, let me end where I started. NASA satellites are looking down at the Earth all the time. The atmosphere, the land, the ice, and the oceans. We capture those observations in understanding, and we capture that understanding in models, and those models let us predict. We know that our climate is changing. We're at about 1.2 degrees so far, and we are still learning about how the whole system works. But we do know that there's an enormous range between the best and the worst outcomes. So at NASA, we are working with urgency to bring you the best observations, models, and predictive tools we can to help inform decisions, locally, nationally, and internationally. Thank you.